Alright, so in this video I'm going to walk through another problem where we're looking at an indefinite integral or integration, and the integrand is just not easy to see the antiderivative of. We just can't quickly see how to take the antiderivative. So when I'm looking at this, I've already kind of mentally tried to simplify this in my head. I just don't see a way that this is going to simplify to make it easy to take the antiderivative. I don't see a way forward. I don't know what this is the derivative of because I'm really trying to find the antiderivative. So I don't know what this is all the derivative of. I mean, I see things that are familiar, tangent, secant squared. That makes me think of stuff like instant trigger for me. Just reminds me of tangent, but, tangent. But anyway, I just don't see what this is the antiderivative of. So when I'm looking at this, all of this is a sign that I might have to use other integration methods. The one that I have in my bag of tricks is substitution. So I'm wondering, can I use substitution to make this problem easier? Now, as I walk through this problem, I'm going to go a little bit faster than the last video, just because we've already looked at the basics. So keep in mind, when I'm using substitution, I'm looking for an internal function. So a function is buried inside of another function. And I'm also looking for the derivative of that internal function. Now, right now, it's kind of hard to see any internal functions just because of the way it's written. But keep in mind that tangent to the fourth is really the same thing as, or can be rewritten actually, as this tangent of x to the fourth. And I guess in theory, so can secant. So I really have, secant of x, and that's squared, and then I have dx. Now, when I'm looking at this problem, I have two choices for a u sub. I have two choices for my substitution, because I've got an internal function here, and I've got an internal function there. But remember, I'm looking for an internal function, a function inside of another function, but I'm also looking for the derivative of that internal function. I'm looking for the remnants of the chain rule. And so when I think about that, the derivative of tangent is secant squared. So I really can see that this is a good choice for the u sub. This is a good choice for my substitution. So I'm going to go ahead and choose that as being my substitution. Come over here and write that down. So u equals tangent of x. That's what I'm going to use as my substitution. And I know I'm also going to need a substitute for dx because I'm going to want to integrate with respect to the new variable that I'm using. So I really need to find du instead of dx. So I'm going to take du dx, the derivative of this with respect to x, and that's going to be equal to secant squared, because that's the derivative of tangent with respect to x. And then I want to substitute for dx, so I'm going to solve for dx here, multiply both sides by dx, divide both sides by secant squared, and I'm going to get du over secant squared of x equals dx. So now that I have my substitution, the very moment of substitute, along with its derivative, or its du, I'm going to go ahead and substitute back in. So when we look at that, what that's going to make this is the integral of u to the fourth multiplied by secant squared. I'm going to write it this way just because I like that better, it's quicker. Multiplied by, and all of this stuff is that. So du or secant squared x. Now when I do this, I instantly notice something nice. All of the variable that I was trying to get rid of, that I was substituting for, secant squared of x, divide, multiply, that's canceling out, leaving me only with the integral of u to the fourth du. Way easier to anti-differentiate than our original problem. So I'm going to take the antiderivative. I'm going to go ahead and anti-chain rule essentially. So I'm going to get u to the fifth over 5 plus c, can't forget that. And then remember, this shouldn't be my answer because u is a variable that I created. I want to tell the reader of my work the antiderivative with respect to the variable that was originally there. And so u for me is really tangent of x. So I'm really going to get tangent to the fifth of x all over 5 plus c. And just thinking through this, because it's always a good idea, this should be the antiderivative of this, which means this stuff should all be the derivative of this. Thinking about that, I'm going to go ahead and take the derivative. This is going to drop out because it's a constant. 5 is going to become a multiplier, going to cancel out with that denominator. So I'm really just going to get tangent to the fourth of x. Then I have to multiply by the derivative of the internal stuff, which is really tangent of x, so secant squared. So I'm going to get tangent to the fourth times secant squared, exactly what I got there. If that was a little too fast for you, go ahead and do that on your own. Take the derivative of this. Make sure that it's great practice. Remember, our whole goal is to beat the AP test together. So hope this helps. Good luck.